Hello everyone, today we continue our bow and arrow tutorial part 4. We will make the character ball to turn in place. Now go to content, create a new folder, name it flag. Open this folder and create blueprint class. Choose scene component, name it BP leg. Create blueprint class, click on actor component, name it BP leg manager. Open blueprint leg, create a new function, name it get foot target location. This is what we will perform in this function. First, we get the blueprint leg world position and set it to restart. We create the line trace from restart to the ray-add with the forward vector, and the length of this line trace we name it raycast length. And if we collide with something, this collide position is the trace position, and if it is not collide with anything, we use the ray-add, use the z vector and trace it downward. And if we collide with something, this is the trace position. Create a sequence, then get world location. Create a new variable, name it restart. Select variable type to vector and set restart with our leg world location. Then get world transform, break our world transform. Use the rotation to get forward vector. Create a new variable, name it ray-add. Another variable, name it raycast length. Select variable type to float. Get forward vector, multiply it, right mouse, convert pin to float. Get our raycast length, multiply it with get forward vector. Get restart, add it with our forward vector result. Set this as ray-add. Add pin to the sequence. Add new macros. Name it cast ray. For input, add new execution pin. Name it execute. Add new input. Select vector. Name it restart. Add another input. Name it ray-add. Create line trace by channel. Connect restart to start, ray-add to add. For drawback type, drag it and type select. Add new variable, name it debug draw. Select variable type to boolean. Choose new category, name it debug. Get debug draw and connect it to index. If it is fail, set it to none. If it is true, set it for 1 frame. For output, add new variable, name it location. Add new execution pin. Name it true. Add new execution pin. Name it false. Get the return value. Create a branch. Connect true to true and false to false. Break out hit. Use location. Connect to location. Get back to get full target function. Call our macro cast ray. Get restart. Connect it with restart location. Get ray-add. Connect it with ray-add location. Create new variable, name it trace position. Select variable type to vector. Set trace location. If it's true, use the raycast location. And if it's false, cast another ray. Get ray-add, connect it to restart. Then get cast length, multiply it by 2. Right mouse, make vector. Connect our raycast length to Z. Use ray-add and minus with our raycast vector. Connect it to ray-add. If it's true, connect location to trace position. Create new variable. Name it target position. If it's false, set our target position as trace position. Add pin. Use our trace position and set it to target position. Now go to blueprint leg manager, add variable, call it legs. Select variable type, blueprint leg. Select object reference. Make variable as array. Add new function, call it can leg and plan. Make function as pure function. Get legs for each loop and go back to leg blueprint. Add new variable. Call it is planted. Set variable type to boolean. Go to leg manager. Array element. Get is planted variable. And array element not equal. Add input variable. Name it leg. Select variable type to blueprint leg. Object reference. If our array element is planted and is not equal to the leg input, create a branch. If it's true, create return node and return it. Add output variable. Call it can and plan. Select variable type to boolean. Set it to true. Create another return node. Can and plan, set it to false. And if the for each loop is complete, this function checks that at least one other leg is planted, so we don't have two legs float at the same time, and they will return that the leg can unplan or not. Go back to blueprint leg. Create new function. Name it check for replan. Create a sequence. Add new variable. Name it foot position. Variable type to vector. Duplicate this variable. Name it to target position. Get the foot position minus target position. Get vector length from this result. Then create new variable. Name it stop distance. Choose variable type to float, and if this vector length greater than stop distance and is planted, create new variable. Call it want to replan. Select variable type to boolean. Set want to replan. For the foot that want to replan, we have to check that if it is planted and length between target position and foot position is greater than the distance that we set it. For raycast length, set it to 10, and stop distance, set it to 10 too. Add new variable. Name it leg manager. Select variable type to blueprint leg manager. Click on object reference and get leg manager. Call the function can leg unplan. For leg, get reference to save. Get want to replan and can unplan. Add new variable. Name it do replan. Select variable type to boolean. Set do replan. We do the replan when the leg want to replan, and we get the allow from leg manager that we can unplan. Add new pin. Get do replan and create a branch. If it's true, create a sequence and set is planted to false. Get foot location and add new variable. Name it plan start position. The variable type to vector. Set foot position to plan start position and add new variable. Name it time seen unplanned. Set it to float. Set time seen unplanned to 0. Add new pin and connect to it. We do this when we do the replan the foot. Now create two float curve. Create curve. Choose float curve and select. Name it step height curve. Duplicate our float curve. Name it step speed curve. Open step height curve. Add time is 0. Add key. Use your right mouse to move the graph. Is 0.5. Add another key. Set the value to 1. At time is 1, add one more key, set value to 0. Select all these keys, right mouse, set it to auto, and go to step speed curve. Make the curve look a little bit less sharp than that. Click on the key, then move it. Add time is 0, add t, add time is 1, add one more key, set the value to 1. Select all the key, right mouse, and set it to auto. Create a new function, name it take footstep. We're trying to find the foot position of the foot, and this foot position used to control our control rig. First we start with plan start position, then we move along the curve to the target position. For stop time is the time that takes from plan start position to target position. Time since unplanted is the time since the foot start move along the curve. Now go to take footstep function, then get is planted, create a branch. If the foot is planted, we return it back. Create a return node, then connect to it. If it is failed, create a sequence. Get time since unplanted, create new variable, name it stop time. Select variable type to float, get stop time. Time since unplanted, divide by our stop time, and create new variable, name it percentage replanted. Set percentage replanted and use this result for the percentage replanted. Create new variable, name it foot position no high. Set variable type to vector, get plan start position and get target position. Create a loop vector, connect our plan start position to A location, target position to B location. Create new variable, name it replan speed curve. Select new variable type, select curve float as object reference. Duplicate replan speed curve, call it replan high curve. Get our replan speed curve, call get float value, get percentage replanted, connect it to in time. Connect this value to alpha, get foot position no high, and set foot position no high by using this vector value. Get replan high curve, get float value, then get percentage replanted, connect it to in time, multiply it with stop time. Set our stop time to 0.8. Right mouse, make vector, connect this value to Z, get full position no high, add it with the Z vector, set it to our full position, add pin, then connect full position to our sequence. This full position is the position that we will update in our control rig. Add new pin, get time since unplanted, and add it with word data second. Set our time since unplanted with this float value. Then set is planted, get time since unplanted greater or equal to stop time. Set this boolean to is planted. Create a new function, name it update foot. Then call get foot target location function. After that, call check for replan function. Then call take footstep function. And create a new function, name it debug. Call draw debug sphere. Then get foot position as the center of the sphere. The radius set it to 4, segment 12, line color set it to green, and thickness is 2. Go back to our update food, get debug draw, and create a branch. If it's true, we call the debug function. And set our replan speed curve to step speed curve. And go to replan height curve and set it to step height curve. Sorry for the mistake that I created. Now add a new variable. Name it stop height. Like variable type, set it to float. Then go to take footstep function. Add the replan height curve. We change the stop time to stop height. Then set stop height to 20. Go to third person character blueprint and select on our character mesh. For preview photos, choose animation mode to use animation asset and choose aim idle animation. Set playing to false and click on capture component. Add blueprint leg component. Rename it to blueprint leg left. Move the blueprint leg left to the left leg. Because this blueprint will recast to the forward vector, so we have to place it behind the leg a little bit. I already experiment with the value location. Set x to 10, y to -10, and z to -80. Go to variable of this leg blueprint. Set recast length to 20. Stop distance to 10. Stop time to 0.55. And stop height to 20. Duplicate blueprint leg left. Name it blueprint leg right. Move it to the right leg. Set location x to -63. Y is 17. And z -80. Recast length, set it to 30 and set the debug draw to true for all the two legs. And don't forget to choose our animation mode to animation blueprint back. Let's go back to blueprint leg. In begin play, get world location, set it to full position, connect it with begin play, and create new custom event. Name it set default value. Name it set default position and call get food target location, get trace position, and set it to plan start position. Set our trace position to our target position and set trace position to food position. Sorry for the mistake that I created to target position. So go to check for replan function, then find the reference of the target position and replace it all with one target position. After that, compile, then delete one target position. Now go to our leg manager blueprint. In begin play, call get owner. Then cast to third person character blueprint. Get the blueprint leg left. Also get blueprint leg right. Get leg array. Add blueprint leg left to the array. And also add blueprint leg right to the array too. Now on update, get legs array. Call for each loop. Call update food function. Go to third person character blueprint, then add blueprint leg manager. Create begin play event, get our leg left, call set leg manager. Then get blueprint leg right, call set leg manager, and get leg manager, connect it to leg manager for both of the legs. Now we get the position from the blueprint that we created. Let's use this foot position to control our control rig arcade. Go to bow and arrow folder and go to animation, open blueprint interface animation blueprint. Add new function, name it set trace turn. Add new input, name it start trace. Let's go to animation blueprint menu. Open event graph. Create a event begin play. Then get character, get component by class, and component class choose leg manager. For the return value, promote it to variable, rename it to leg manager. Get another character, paste it to third person character blueprint. Get leg left blueprint and promote it to variable. Get leg right blueprint and promote it to variable. On update animation, add another pin. Get leg manager and check if it is valid. Connect it to our sequence and get blueprint leg left. Get foot position. Promote foot position to variable. Name it foot position left. Then get leg right. Get foot position. Promote it to variable. Name it to foot position right. Go to anim graph. Create a control rig. Connect it to output post. Add the control rig class to COLEG IK. Then open our control rig COLEG IK. Set left foot position to public, right foot position to public, and start trace to public. Get transform control. For the translation, subtract it with Z vector is 4.5 to lower the pelvis a little bit. Go back to animation blueprint menu, click on control rig and tick on left foot position, right foot position, and start trace. Create a new variable, name it start trace. Get foot position left, connect it to left foot position, and get foot position right, connect it to right foot position. Get start trace and connect it to start trace. Go to event graph, create a branch, get the velocity is not equal to 0, 0, 0. Connect it to the branch, and if it's true, set start trace to false. Get our aim variable, create a branch, create do1. When start trace is false, connect it to reset. If aim is true, connect it to do1. And get our left leg, call set default position. Get our right leg and call set default position. Set start trace to true. Call event set trace turn. Get aim variable. Create a branch. If it's true, set our start trace to start trace variable and connect it to reset of the do1. Now go to third person character blueprint and create a custom event. Name it camera zoom and another custom event. Name it camera unzoom. Get mesh and get anim instant. Call set trace event. Call set trace turn event. When camera zoom event, set start trace to true, and when camera unzoom event, set start trace to false. Now go to our aim ball event. When the aim is false, we call unzoom event, and when the aim is true, we call camera zoom event. Add camera zoom event. Get character movement, set rotation rate. When it zooms, set to 100. If it unzooms, set it to 300. And this is the result that the character about to turn in place. In the next video, we will make our character about to aim down and aim up by adjusting the spine of the character. If you have any question, please leave it in the comment section below, and please subscribe to my YouTube channel. It really means a lot to me. Thank you very much for watching this video. See you in the next video.